Hello, algebra students. Mr. Lawrence here, and I wasn't intending on making this video. I was intending on teaching you today in class myself, but unfortunately my back has been acting up. It started last night at conference or before conferences, and I'm going to have to go see a doctor and see if he can't do something for me. So hopefully just for today, this will be a substitute, but you should have already watched the part 1 video. And in there I go over the basics of substitution, solving a system of linear equations by substitution. Here I'm going to go with just a couple more examples so that you have plenty of examples. Now remember, you can't just watch these videos and then try the homework. You have to do the problems. You have to take notes. Okay? So before I do this one, I want you to pause the video and see if you can figure out what to do first. All right? I'm going to tell you what I want to do first, but try and push yourself. You'll get more from the experience if you do that. And remember to use the homework help in Math Excel. Okay, so here we go. Hopefully you've tried this problem on your own. First, I have to decide which variable to solve for. And I look at both x's and both y's. I see that solving for this x might be a good idea. The reason I say that is because at some point I'm going to have to divide by 2, and I know 2 goes into 6 and into negative 10 evenly. Okay. Similarly, if I solve for y in this equation, the second equation, 3 goes into negative 6, oh, negative 3, excuse me, negative 3 goes into negative 6. It also goes into negative 15 evenly. So it's up to me which one I want to do. There's no wrong answer here. There's a lot of different reasons why you might choose to do it. I think I'm going to choose to get rid of these negatives and deal with these negatives now. So I'm going to solve for this y. But if you'd rather solve for that x, there's nothing wrong with that. Okay? I think solving for either the y in the first equation or the x in the second equation is going to be a little problematic, give you some difficulty, because the coefficients on those variables don't go evenly into the other coefficients or the constant. All right, so anyway, let's solve for y in the second equation. First, I'm going to add 6x to both sides, and that will give me the equation. Be careful here, don't drop your negative. Negative 3y equals 15 plus 6x. And now I need to get the y alone. I'll divide by negative 3. And remember, do it 3 times. I've shown many of you that. It's not wrong to do it once, but sometimes it makes it a little difficult to get a simple enough equation. So here the negative 3's cancel, and I'm left with a y. 15 divided by negative 3 is negative 5. 6 divided by negative 3 is negative 2. And then an x. And I don't like that plus being there. I don't like double signing. So I'm going to go ahead and get rid of it. So I have negative 5 minus 2x. All right, now I'm ready to substitute. Remember, you must always substitute into the other equation. So I know that y is the same as negative 5 minus 2x. I can't put it here where this yellow, where the y is highlighted in yellow. If I do that, I'm going to get an infinitely true statement no matter what the solution to the problem. And it's simply not true. I can get an infinitely true statement in these problems, and I'll talk more about that later. But the point is, I have to substitute into the other equation. So when I do this, I'm going to have 2x plus 6, and then I'm going to put in a negative 5 minus 2x in place of y because they are equal to each other, and that's going to equal negative 10. All right, so now I'm going to distribute, making sure to pay attention to my signs, and I will get 2x minus 30 minus 12x equals negative 10. My next step will be to combine like terms. You should be able to see the like terms here. I'll highlight them, 2x and a negative 12x. Notice I count the negative with the 12. It's not 2x and 12x, it's 2x and negative 12x. So when I combine those, I get a negative 10x minus 30 equals negative 10. I will add 30 to each side because here I just have a normal two-step equation, something I'm very comfortable with. So I'm not explaining quite as much. Divide by negative 10, divide by negative 10, then x is going to equal negative 2. All right, now remember, I'm not done with the problem. I have to solve for y, but the beautiful thing about substitution is I will always have an equation at this point in the problem that has the variable I'm looking for isolated, like right here, y equals negative 5 minus 2x. So I'm going to substitute negative 2 in for x. So I'm going to get 5 minus 2 times negative 2. Okay, I'm going to have y equals negative 5, and then this here, negative 2 times negative 2 is a positive 4. And a negative 5 and a positive 4 is a negative 1. Okay, so my solution is negative 2, negative 1. If I would have solved this on a graph, the two lines would have intersected at negative 2, negative 1. Okay, right here, same problem. Now that you've seen me run through it, why don't you try to run through this one totally on your own? Pause the video and see what you can do. Okay, here we go. I'm going to solve it now. I am already decided I'm going to solve for y in this equation because it's going to produce the friendliest numbers. And so I'm going to add 15x to both sides. And that'll give me a 5y equals 50 plus 15x. And then I'm going to divide all three terms by 5. And I will get y equals 10 plus 3x. Okay, now I'm ready to substitute. And remember, I must do that in the other equation. I'm going to put the 10 plus 3x in for y there. Okay, so I'm going to get 2x minus 3, and that'll be times 10 plus 3x, and sorry, that was in my way. Where am I? Equals 9. All right. So I'm going to distribute so that 2x doesn't get changed. I'll have a negative 30 minus 9x. That's going to equal 9. I'll combine like terms and get a negative 7x minus 30 equals 9. I'll add 30 to each side. And that'll give me negative 7x equal to 39. And ooh, this answer is going to be a little bit ugly, but that's okay. All right, and so when I do that, I'm going to go back here and check my work because I'm surprised I'm getting such an ugly answer. Let me see here. I've got add 15x to each side, divide by 5, 10 plus 3x, negative 30 minus 9x. Yeah, it's looking right. I don't see any mistake. Negative 30 minus 9x, negative 7. Okay, so I'll divide by negative 7, divide by negative 7. Now, a lot of you like to leave your answer as an improper fraction here, and that's not wrong, but to me it doesn't make any sense when I'm trying to talk about a place where the lines intersect on a graph. I'll use the negative 39/7 in my calculations because it'll be easier. When I'm reporting my answer, I know that 7 is going into 39 5 times. 5 times 7 is 35, which is 4 short of 39. And there's my x-coordinate. Okay? Now I'm going to substitute this in here. So I'm going to get y equals 10 plus 3 over 1 times negative 39/7. Fortunately, nothing here is going to cancel out. So I'm going to get 10 minus 3 times 39. Well, let's see. 3 times 30 is 90. 3 times 9 is 27. It's going to be 117. Okay? Now, I'm going to turn this into a fraction with a denominator of 7. So I have to multiply the denominator by 7 and the numerator by 70. And I'm going to get 117 sevenths, right? If you don't know how I did that, come see me. I would love to help you. All right, so now I have like terms, so I'm going to do 117 minus 70, knowing that my answer won't be what I get when I subtract here. It'll be the negative of what I get. So I'm going to get 7, I'm going to get 47. So y is going to equal negative 47 sevenths. And again, for purposes of reporting my answer, that's going to be negative 6, be 42 and 5 sevenths. So the place where these two cross will be negative 5 and 4 sevenths and negative 6 and 5 sevenths. Something you couldn't have known if you were solving by graphing. All right, now there's two strange situations I want to talk about really quick. One, sometimes you will do the work and you will get an infinitely true statement. You will do this, assuming you've done everything correct. If you get a statement where the variables disappear and you get an infinitely true statement, then you know that this system has infinitely many solutions. By the way, be careful. 3x minus 3x does not equal x, right? Some of you will get that. You'll have a 3x, and you'll have a plus 6 equals 6 plus 3x, and you will do something like this, and it is utterly ridiculous. Okay, you'll do this. This is smart. And then you'll go, okay, I got a 6 here, I got a 6 there, those cancel. Oh, I've got an x left. No, you don't. This does not equal x. These cancel just like they did on the other side of the equation. So you end up with the equation 6 equals 6. Assuming you did everything else right, if you get that, there are infinitely many solutions. Similarly, sometimes you'll have this, and you'll subtract negative 4x from both sides, which is a very smart thing to do. And you will get 7 equals negative 3, which is never true. In this case, there is no solution. I'll bet if you check the slopes, you'll find that the lines are parallel. No solutions. Okay? All right, that's it for the second of the two videos. Please make sure you've watched both. Good luck on the homework and have a nice weekend. Mr. Lawrence signing off. Have a good night, everybody.